All right. Hi, guys. We are going to learn about graphing calculators today. Since this is a new era that we're living in, I feel like, we cannot hand out graphing calculators. Some of you have them, which is great, and you can use them on the ACT and everything. You can use them in college. So if you do have one, use your time in class to ask questions. It won't take very long to help you figure out how to do it. We've done a lot of this in Algebra 2. So this might be a review and you can do everything on the calculator and that's fine. If you do not have one, then we're going to use Desmos. Okay. So first of all, analyzing graphs. So how do we know if these graphs will have a maximum or minimum? So the maximum value or minimum. So if you would look here, and I should flip this. Oh, no, I don't want that. Because I need, okay, so I'm going to have to do this on a regular computer instead of a tablet. Okay, so let's make a pretty color. So how do we know if the maximum or minimum? So here, your A value, if you remember, your A value flips if it's negative. Well, this is a normal x squared graph, so it would normally look like a parabola, except now it's flipped. So it looks like this at some point on the graph. So that means this is going to be your maximum. Now, for an absolute value, you know it normally looks like a V. Well, we want to look at your A value, and you know it's stretched, but it did not flip. So it's just skinny. So this is your minimum. So use some of your previous knowledge that you worked on last chapter of your A value, of if it's flipped or not, to know if you're going to need a maximum or minimum value. Okay. How do we know what it is? That's going to be your H and K. So remember, H and K moves it right and left, right and up and down. So if like this one, there you go. So that is your H value and your K value. So your first problem over here would be 7, 3. So let's zoom in a little. And this one would be 7, 3. Because of your H and K, your minimum here would be 3, -1. Okay? So that is a little bit about what we're going to be doing, except we're going to do things on the calculator. I'm going to show you on the Desmos, but you can use some logic too. Okay, so when you're given a equation, so you need to put this into your graph. So x, and then you're going to use, I use the caret button, which looks like the upside down V, to the third, and then I just hit arrow over, plus 3x, and then I have to squared. I just hit arrow over to get off of the exponent, minus 5x minus 5. So here's my graph. So now I look at find x when f of x is 7. Well, I have to remember that this is my y value. Okay, so f of x is your y. So now I look at y over here on my graph. So if I want 7, so what I could do is put in 7 for my y here. Maybe I need y equals 7. There you go. So now, guess what? All you have to do is hover over each of those values, and there's 3 values. So your first value is negative 3.439. Another one is negative 1.661. And then your last one, that was 2.1. Whoops. Sorry, guys. There's the bell. Okay, so there is my 3x values. Now remember, look at this 0. Is this part of the graph? No. This is just showing you where the y-intercept is. So make sure that you're not putting that point down because it doesn't cross the graph at 0 because there is nothing at 0. So now, since we're done with that, I'm going to erase. Whoops. And I'm going to put, now f of negative 3 is x equals negative 3. When x equals negative 3, you just hover over, and I see that that equals 10. So this equals 10. Pretty slick, huh? Now find all real zeros. Real zeros, remember, are your x-intercepts. So that means y equals 0. So you need to go here and look at all those points. Remember 0, 0, it's just showing you where the y-intercept is. Now if you click them, they stay. So then you can write down all real zeros, negative 0.9460, negative 0.7480, and then my last point is 1.6940. So a lot of these ones that we do on the calculator are going to be really icky. The ones that we do as a real graph is going to be by hand is going to be a lot nicer. Okay. All right. So here, all I have to do is click the graph, and I'm clicking the maximum, and then I click the minimum. That is your relative maximum or minimum. So now I write max. And my max is going to be negative 2.633, 10.709. My min is 0.633, negative 6.709. All right, so pretty easy so far. Now I'm going to zoom out a little bit, and you see that the graph goes on forever and ever, okay? So there's like arrows here and arrows down. So my domain, if I do my little sheets that I did on day 1 of domain and range, I would cover up an arrow to an arrow, so that means your domain would be all real, and your range would be all real because it would be an arrow on bottom and top as well. So your domain and range, you just kind of have to look at the graph and see. There's not really any hints of how to do that, okay? All right, so let's do another one. And once you have your graph kind of, or your equation there, you could just change it a little bit, like me. Minus 2, but now I need a x squared. Hello. There we go. X squared minus 4x plus 1. Okay. So now I already zoomed out, so I kind of want to zoom in a little bit. And you can zoom in and out as much as you need. Okay, remember this is my y value. So down here I'm going to put y equals 7. And there are my 2 points. So that's what I write down. So my x is negative 1.226 and 2.648. My next one is x equals negative 3. So I have to go up quite a ways before I find my point. And you can, especially when you're doing it not split screen, you can make it the graph bigger. It's hard to do it on a split screen because you can't have your graph super big. So this is going to be 103 because that is your y value. Okay, so sometimes you got to play around with it a little bit. Your graphing calculator will just automatically find it. It's kind of easy. So now here is y equals 0 if I'm finding the real zeros. So now I have to go back down. Whoops. It's a little harder. When you don't get to see your whole graph. All right, there we go. And there's the point, and there's the point. So my real zeros are 0.2230 and 2.430. Now, relative maximum and min. So since I'm done with that, I can get rid of that equation. So if I want to click this graph, I just want to click on the lowest point. So now here, this one only has a min. It does not have a max. 1.691, negative 8.142. So hopefully you guys are doing this with me and not just watching me, because it's kind of confusing if you don't just do it. So hopefully you guys are doing it. So now domain and range. So if I look, my domain, there is an arrow over here and an arrow over here, okay? So it goes up forever on both. So your domain is going to be all real. But now your range, do you see how your range doesn't go beyond this point? Well, beyond this point, you see that your y value is negative 8.142. So my range has to be negative 8.142. And your y values are greater. And it equals that point because it touches it. But it goes up forever. Whoops, so I should have written it the other way. So, excuse me. All right, so y is greater than or equal to negative 8.142. And that is your range for this graph, okay? Because it only goes up, it doesn't go down, so it only is x is y is greater. Okay, so that's a little bit how to use your Desmos calculator. Message your teacher, message whoever to help you figure it out if you are lost. The Desmos graphing calculator, there's a lot of tutorials out there, so you could search for those as well. But it's kind of a cool feature if you can use your computer, which like the ACT you can't. But in this class we can so far. So good luck. Try it on your own on your Chromebook. See if you can figure out all of the answers. Make sure you're checking your answer key to make sure you're getting them right. Good luck.